Greetings, everyone. My name is Courtney Muma, and I'm Deputy Director of the Texas Digital Library. Today, I'm pleased to welcome you to another in our series on topics in research data management. This is a free webinar series hosted by the Texas Data Repository Steering Committee and the Texas Digital Library Consortium. First, I want to introduce you a little bit to the ins and outs of Adobe Connect. You'll see that in the top left, we've got the attendees pod, which contains information about our hosts, presenters, and participants. In the middle left, that's our chat pod, where you can drop in your questions and comments throughout the session today, and we'll try to answer them when we can. And you can also direct message individuals. And then in the bottom left, it's our download pod. That's where we share files that you can download, and you'll see there we've got a PDF copy of the slides from today, which we'll also provide alongside the recording after today's session once we get closed captioning done. So the Texas Data Repository is a multi-tenant Dataverse application, and it was launched in late 2016. Dataverse itself is an open source web application to share, preserve, cite, explore, and analyze research data. There have been 11 TDL member institutions who have served on the TDR steering committee in order to provide feedback and make decisions about TDR services. The purpose of that committee is to provide strategic planning support and policy oversight to ensure focus and direction of our programs and our services. So today, in our Topics in Research Data Management series, we have some guests from the University of British Columbia that we're excited to introduce you to in a minute. But I want to let you know that we started this series about a year ago, kind of completed it this summer, and then have decided to continue it this year. And I want to thank specifically Jessica Tree-Logan of the TDR Steering Committee, who has really taken this on as her project. And this is the first in kind of the continuation of the series. When you want to review any of the recordings or products of the series up to this one, you can go to that link on the tdl.org site, and you can find our recordings and all of the slides from previous Topics in Research Data Management webinars. And thanks again, Jessica, for taking this on and organizing the next set of speakers. So today's guests, without any further ado, are from the University of British Columbia Library. I am a proud alum of University of British Columbia. That's where I got my master's in archival studies and library and information studies. So very, very pleased to have some UBC folks here today. We have Eugene Barsky, who is the research data management librarian, Paul Dante, the software engineer for the Geodisy project, and Mark Goodwin, who is the metadata coordinator for the Geodisy project. So I'm going to go ahead and hand it over to our guests. And again, please make sure to add your questions and comments in the chat.
Hello, everybody. My name is Eugene Barsky. I'm a lead PI on this project. Can you hear me, Courtney?
Yes.
Good. So today we just wanted to have a quick conversation about the work we have been doing with the geospatial data discovery. But before we start, I just wanted to provide some background about the, we are just finding a way to switch slides, about our funding for this project. So our funding comes from an institution called Canary. Canary is similar to Exceed in States, is a backbone for our national high-performance computing in network. So in Canada, we tend to work collaboratively because we are a very small country. We are very large geographically, but very small population-wise. So we tend to work together on many initiatives. So Canary and Compute Canada have allowed us to connect different institutions and high-performance computing all together. So Canary funds the research software projects, and we are one of them. They also fund some national research data initiatives, like the National Summit for Research Data that some of you have attended, and we also provide the identity management. So if you go to use Eduroam in any kind of institution, Canary is the institution that supports it. And they also provide some cloud resources, sorry, and then networking for the technology sector. So since they do provide some funding opportunities, Okay, so you have to get used to the slide switching. You think so?
Yeah.
In Canada, we have been building research data management services for the last 5-6 years. Again, we have done it collaboratively between various institutions as much as we can. So we have a national Dataverse in Canada being implemented right now out of Scholars Portal, University of Toronto. We have a national discovery service for data, which I will be showing you in a sec. We have a national platform for data management plans. We have a national platform for data networks and so on. So this slide just quickly shows us where we're standing with national services. So around 15 months ago, Canary came with their first funding call for research data management, and we have received one of the funds to supplement our national discovery service with a map-based interface. So as we go now today, if you haven't seen it, Canada runs the National Discovery Service called Further. I know it's a funny name, but it's a federated research data repository. The software has been developed in the UBC. The front end has been developed in the UBC, but now we run it as a national service. So it's the place where we can amalgamate and harvest all Canadian research data repositories. So all our databases, all our islandors, all our DSpaces, all our local repositories like a Hawkeye Institute or small social science institute. So Further allows us to bring all this data together as a text-based search engine. So we allow people to search for data by typing keywords. So our project came and wanted to supplement that by using geospatial search features. So we want the Canadian research data to be searchable by geospatial location in addition to text. So I will let Mark lead us through it for the next steps.
Okay, thanks very much, Eugene, and thanks everyone for having us and for the introductions. Just a quick personal note. I know we've got some folks over there who are familiar with UBC. I actually did my practicum at the University of Texas, which was a wonderful experience. So feeling very humbled and honored to be speaking to all of you. So Paul and I are going to switch over and focus specifically on the project now, on Geodisy. Okay, so the aim of the project, as Eugene said, it's a map-based tool that will allow Canadian research data to be searched, filtered, and browsed using geographic locations in addition to text. So a few key points here. The main kind of portal for searching is an interactive map, and data is displayed based on the location at which it was collected. It's going to be a part of Further's infrastructure. Eugene just showed you our national data repository, Further, and it's a repository and discovery layer. So it currently has a text-based search, and our tool is going to provide a map-based alternative to the text-based search on there. And similar to Further, it's going to be, the idea anyway, is for it to be an aggregate of sources from across Canadian institutions and organizations, and government bodies, things like that. We're starting out with just a pipeline to Dataverse, and Paul will talk a little bit more about that. But yeah, the idea long-term is for it to be kind of an aggregate, one place a user can go to look for data from a number of different sources. And one thing we see really setting this tool apart from other kind of geospatial search tools is that we are including not just data that is kind of typically geospatial in nature, but we're also including anything associated with a location. So, for example, could simply be a survey of, Vancouver, and we're going to actually generate a bounding box around the city of Vancouver, and then it would show up on the map search as being located in Vancouver. So there's most tools similar to this in use focus more on geospatial data, but we're kind of going for a broader approach that we hope will be useful across a number of different subject areas and professions. It's also going to be all open data. It's going to be openly accessible to the public as well. So why use it? Why do we think it's neat? Because data can be hard to find, especially if location is a significant aspect of what it is you're searching for. So if you're using keywords to describe a place, as I'm sure many of you know, it can be challenging. It can be kind of hit or miss sometimes. An example that I've been using is a friend of mine who's she's researching tree lines and climate change impact on tree lines in an area that's kind of in northern BC and pokes into Alaska a little bit and a few other areas. It's not an area that's really defined by official borders, but if she wanted to do a search for data or information available on this area, and if she had to build a text search, you might be looking at something like this, where you start with, okay, it's in British Columbia, so you have to think of different terms for BC. You're also only looking at northern BC, so you've got to include that. Well, we're also thinking about Alaska and the Yukon here a little bit, so those have to be incorporated. And you might want to think of park names, because maybe someone deposited something just with a park name attached to it, and there's multiple parks, and it might be called a preserve or a reserve, and so on. And you can see it can get tricky really quickly. So with Geodisy, much nicer. The idea is to just have that nice interactive map that you can zoom into the location and get all the results you need that way. So what you're looking at right now is actually NYU's spatial data repository. They're using the same interface that we're using for Geodisy. Unfortunately, we were planning on showing you our alpha demo version that we have. We just got it running last week, but it doesn't seem like it's going to be possible with the webinar tool here. So what we'll do the next best thing and show you some screenshots here. So it's probably, ours is going to look very similar to this, probably. So you can see here the main kind of search portal is that map window there, and wherever you zoom into on the map, it'll refine the results to reflect what's within that area. So you can see right now in this kind of section of Alaska, British Columbia, and Yukon, there's about 2,500 data sets in NYU's collection. And if you hover over a record, it'll show you the bounding box. That blue box is the area where that data is located. And then you can see there's some options for filtering and limiting the results along the side. And if you click on one of the records, you'll see something like this. So this is switching over to New York City. And if the data is geospatial in nature, you'll get one of these nice previews here. If it's, like a shape file, for example, like what we're looking at here, you'll get a nice preview on the record page, and that map is also interactive. You can zoom in and out and move it around. So you get some basic metadata here, including a link back to the original source for the data. So we're driving traffic back to the original repositories as well. There's some options for downloading the data on the right-hand side. One thing you don't see here, but we will also be providing, is a metadata file in ISO 19115 XML format. So this is a kind of internationally recognized geospatial standard for metadata. I'm going to talk a little bit more about that later, but that is something else that's going to be provided here, available to download. So I'm going to turn it over to Paul now, who's going to talk a little bit more about how this all works.
So Mark talked a bit about sort of what the project is. He used some terms that maybe aren't familiar to everyone, and then I'm also going to use some terms that are probably not familiar to everyone, in part because we somewhat made them up. So the first one, metadata, many of you probably know what that is, but for anyone who doesn't, metadata is describing a resource. So the sort of classic example is with a song, the metadata are things like the title, the duration of the song, how big the file size is of the song. So it's data about data. For us, we are talking about two different types of data. The first is geospatial data. And so we're defining that as anything that has a geospatial file type associated with it. So a record that has a shapefile with it, or a geotiff, anything that you could put into a GIS program and map it out is a geospatial file for us, geospatial data. When you're looking at locations in records that don't have those files, for us, we're calling that quasi-geospatial data. So if in the metadata it says that everything was recorded in Vancouver, British Columbia, that is a quasi-geospatial data if there's not a file associated with it. And the last one is bounding boxes. A bounding box is the smallest rectangle that incorporates all of the data in that data set. So it could be all the points that are in the shapefile, a bounding box that incorporates all of them, or in the case of, again, with Vancouver, it would be a bounding box, be a rectangle that includes all of Vancouver's area. One thing sort of interesting about our project, it is entirely open source. We are storing all of our code itself on an open GitHub repository. There's a link to it at the bottom. There's also a documentation. We're also using a number of existing open source components because it seemed like it would be a waste of time and resources to reinvent things that other people have already created. The main three that we are using, we are harvesting from Scholars Portal Dataverse. In our middleware, we're using GeoServer, which is being used for the previewing of geospatial datasets. And then our front end, which you saw screenshots of through Mark, is GeoBlacklight. We have a few other components, GDAL and Geonames, but I'll mention those in a little bit. This is the general architecture of our project, sort of broken up into sort of three areas, three cloud instances. So there's a Scholars Portal is off by itself. We are harvesting there into our middleware, which is where most of our code is. And that's, the Geodisy middleware. And then GeoServer is also in that middle VM. And then the front VM is where GeoBlacklight sits, and that's where most people would interact with Geodisy. So the pipeline for Geodisy has sort of eight main steps that we go through. The first one is we are getting data sets from Scholars Portal. We are hoping to expand that to other Dataverses in the near future, and we've also applied for funding to expand to other repository types. But for right now, we're doing Scholars Portal, which covers the University of British Columbia, University of Victoria, a number of Ontario universities, and a few in Alberta. From all of the data sources that have any sort of location-based information, we're harvesting metadata. So that's going to change. Then from ones that are geospatial in nature, so they have geospatial files, they're actually harvesting those data files as well. We are then enriching the metadata. So we're generating bounding boxes if there is a way to generate a bounding box for that metadata. We're using GDAL to read geospatial files. It's an open source software project that can read geospatial files and provide information about them, including bounding boxes.
Just a question.
Yeah. I believe that Scholar's portal dataverses are all...
One installation with multiple tenants. Yes, we have more than 35 now and growing. All Ontario, all Quebec, some Western schools, and all growing. The plan is to move all Canadian schools to Scholar's portal Dataverse in the next year. Thanks, Jessica, for the question.
Thanks for the question.
Yeah. So we're generating bounding boxes. In some cases, there might already be some bounding boxes in there, and then we may or may not, depending on some rules we set up that I'll talk about in a minute. As Mark said, we're generating ISO 19115 XML metadata. We are also creating GeoBlacklight JSON files because that's what GeoBlacklight, our front end, uses for its searches. The geospatial files themselves that we've read are then getting put into GeoServer, where they can be previewed by by GeoBlacklight. We're then pushing all of our metadata to OpenGeo Metadata, which is a GitHub repository that a number of universities, mostly in the US, but some other places as well, have put their metadata and GeoBlacklight data in one place. So if anyone wants to harvest, you can actually go there and get from, I think it's probably from about 10 different schools, and it gets you around 50,000 geospatial records. So ours will be there as well. And then lastly, GeoBlacklight will get that metadata from our middleware, and it'll be searchable on its platform.
Okay, back to me now, Mark. I'm going to talk a little bit about more about the metadata and how the how we treat the metadata through the Geodisy process. So initially, probably this is review for many people, but just to give some background here about terminology. Metadata schemas are structured series of metadata fields that describe a resource within a specific environment. So for example, Dataverse has its own metadata schema. Standards are same kind of thing, a structured series of fields or elements, but the difference being that they're overseen by a national or international group that keeps them standardized. And then crosswalking is when you take the elements or fields from one standard or schema and map them over kind of field to field onto another standard or schema. Another quick note. Decided that we're just going to wait until the end for all the questions. So thanks, Michael, for the question. I think we'll just address everything at the end. But feel free to type them in there in the meantime. So this is a diagram of how the metadata kind of goes through Geodisy. We start with the Dataverse schema and all the metadata that the researchers deposit with their data sets when they put them into Dataverse. So we're taking that, and there are two outputs that are coming from this. One is the GeoBlacklight schema. So as Paul mentioned, that's the GeoBlacklight JSON. So this is just the kind of basic metadata that GeoBlacklight uses to function for its searches. title, author description, some geographic information in geometric type and things like that. And then ISO 19115. So this is an international standard. ISO stands for International Standards Organization, I think. So they have got a whole bunch of different standards, and 19115 is specifically for geospatial data. So this one is kind of like a much more complex, thorough standard that allows for a really full description of a resource. So the ISO files, as Paul mentioned, are going to be part of Open Geo Metadata, which a number of US schools are using, you may have heard of. So it can be kind of batch harvested from there. And then we're also providing those metadata files on the record pages in GeoBlacklight. So they'll be accessible there too. And then that little box in the middle, the Geodisy generated metadata, is some of the metadata that we're adding to kind of enrich things a bit. Most of it is based around geographic information that we get if we're reading the geospatial files. If they do have them and we're able to read them, then we actually take some of that information and add it to the metadata. And then we also include some information about Geodisy itself and how and Geodisy's process. So this is a link to an example of an ISO 19115 file. I'm not able to open it in this webinar platform, but feel free to click on it and take a look. It's from the US Geological Survey. So it's really, it just kind of shows how thorough and working with it can be a little tedious at times, but it really does allow for a nice thorough description of the resource. And in the XML, you kind of build hierarchies based on different packages of metadata, unlike some other metadata standards, which are just more of like a flat list that might be in categories. It actually uses packages, this one does, that can be repeated for different purposes. So it is quite a powerful tool. Now I'm going to give it back to Paul, and he'll talk about bounding boxes.
So bounding boxes are sort of the most important part of the metadata for our pipeline, in that without bounding boxes, our pipeline cannot function. GeoBlacklight uses those bounding boxes for determining what records are in a given area. So we have to have a bounding box in order for a record to be displayed. If we can't either get a bounding box from the metadata or from a geospatial file, we can't use that record. So one result of that is that while we are going to be harvesting from many of the same sources as the rest of the Furter platform, we will be a subset of that, because not everything has a geospatial component to it. So in Dataverse, there are a few different places, or a few different fields that are geospatial in nature. In the geospatial metadata block, there are sort of two places that we are looking for generation of bounding boxes. The first one is the geographic bounding box there. The second one is the geographic cover. We decided that we wanted the data that goes to our pipeline to be as accurate as possible, and we preferred to have accurate records, so when people are doing searches, they get stuff that's actually relevant, rather than being a bit more lenient in terms of what went through, but potentially having records that were not for the correct location. And for that reason, we set up a series of rules of how we would generate bounding boxes, or determine what bounding boxes to use. The very first thing we try to do is look for a geospatial file that we can generate a bounding box from. We felt that this would be the most accurate representation of the data set, because it is actually the data set. So if we can do that, we use GDAL and we try to generate a bounding box from that. If that fails for whatever reason, either there isn't a geospatial file, it's not of a format that GDAL can read, or there's something wonky in the file and we can't get a bounding box. We go to the second option, which in the metadata from Dataverse, is a geographic bounding box, or are geographic bounding box fields. So if that's there, that's our second option. It does have to have all 4 coordinates. There can be multiple bounding boxes entered. We're fine with that, but there would have to be at least 1 complete bounding box entered for us to use that. If that doesn't work, then we use the geographic coverage fields, which would include country, nation, state, province, city, and other. In the interest of accuracy, we decided that we sort of had rules set up for what needed to be entered in the geographic coverage for it to be valid for us to search for a bounding box in it. We are using Geonames, which is an open source project where you can programmatically send in a place name and it gives you back information about it. So we decided that because of there being many places that have similar or the same name, that there had to be a certain hierarchy set up. So one thing we thought about is, like, if someone just puts in Vancouver for the city and that's all they have in there, being in Vancouver, we love to think that it's about us, but the reality is that there is a Vancouver, Washington, which actually technically was founded like 30 years before Vancouver, British Columbia. And so if it just had the city Vancouver, we are not using that as a bounding box because of that ambiguity. So for us, the most important field is the country, nation. That has to be in there. And so then from there, if you have the country, you can also then use state or province. If that's there, then you can use city. The other field is, because this is an open text field, we do not know what's going to go in there. There could be anything. And for that reason, we actually have it set up that we are flagging any file that has the other that we are trying to generate a bounding box from the geographic coverage. And then we're going to have someone who currently is Mark look at those files and see what we can do with those files if the other affects things, and then move forward on that record a bit more manually. So yeah, as I said, if we can't generate a bounding box, we are not going to deal with it. We're just going to ignore that record. I'm going to bring it back to Mark, who's going to talk about sort of some examples of what I was just talking about with the hierarchy.
Right. Okay, thanks, Paul. So yeah, these are just kind of some case studies that we ran into as we were figuring out how everything was going to work when we started pumping all the data in here and generating these bounding boxes. So like Paul said, we've got this automated system set up for generating the bounding boxes. And then if it doesn't meet any of these requirements, then we do ignore it. But then, like Paul said, we also have this process for logging certain data sets that do have some of the information and seem like something that would be useful, but they're not getting we're not able to automatically generate them. We have to actually look at them for manual review. So these are just a few examples here where we'll look at whether we can automatically create a bounding box or whether it's going to get logged and added to my work pile. So normally I get people to raise their hands or give a thumbs up, but it obviously won't work over webinar. So I'll just kind of go through them here. You can think in your head whether you think we'll be able to automatically generate one or not. So starting with this one, I've shown the Dataverse geographic metadata block here, and then I've also put a note as to whether there is a geospatial file as part of the data set as well in the little left-hand corner there. So this one is great. This one's all good for an automatic bounding box. It does not have a geospatial file, which, as Paul mentioned, is our first kind of step that we look at. But then it does have a nice set of coordinates there that we would use. It's also got geographic coverage entered, which is fantastic. We wouldn't need that for the bounding box because we use the coordinates, but it's great for the metadata. So this one, Paul kind of alluded to the issue with this already. This would be logged. So obviously there's many different spring fields. We wouldn't know which one it is. So we're not just going to throw this one away. It would be logged for manual review, and that manual review would likely include contacting the author to try to get some more clarification. This one here, so a nice set of metadata, but logged because the other field is filled out, and we don't know exactly what's going to go in there, as Paul mentioned. In this case, you know, it's great. It's a good thing they filled out the other field. The depositor is, you know, being as specific as they can be, which is great. This would be an easy one for me to just pass through. We would just create a bounding box for Stanley Park. There would be no need to, you know, contact the author or anything here. This one, we're good because it includes a shapefile, which you might not have been paying attention to, the text in the bottom left corner, but if it's got a geospatial file type, then we are we're good as long as GDAL can read it. Shapefile is one of the file types that GDAL is familiar with, one of the most common geospatial file types. So even though it could be Paris, Texas, which is actually fitting for this presentation, we would be good to go with this one. This one is a no-go. If you look closely, Vancouver is misspelled. So hopefully this would be logged because we're kind of relying on Geonames, which Paul mentioned, kind of a database of place names for to accurately recognize when we need to rely on geographic coverage as the means for generating the bounding box. So if it's misspelled, we're hoping it would just not find a match.
One thing to note about Geonames is that in addition to sort of the main record name for each location, it has a fairly extensive list of alternate names, including a lot of different languages, including non-Roman character languages. So people can be searching in languages other than just Latin-based languages and still be able to find the records.
Right, good point. Okay, I think this is the last one. So here we have two separate geographic coverage entries. And this one is all good. We can do a happy dance because what we would do here is create two separate GeoBlacklight records. And each would have its own bounding box based on these two locations. And then when you search for them in GeoBlacklight, it would show as a series like of the data set's name, 1 of 2, 2 of 2, and then they would link to each other as well. So we had planned to show you our kind of very early stage alpha version of Geodisy that we just had up and running. Unfortunately, that link won't work for all of you because we have to manually add IP addresses. It's currently IP locked right now. But if you would like, feel free to send us an email. I'll put our email up here in a second, and we can add IP addresses, and you're free to check it out if you like. This is a list of all the wonderful people on our project team. We've got a core team based out of UBC and a number of project partners throughout Canada and different organizations. So the plan, we've kind of got this this early version working now. We're going to do some user testing. We're testing all the functionality of it and all that kind of stuff. And the idea is for us to launch in spring in a few short months. So should be hearing more about it at that time. And we've got a few methods for you to keep up to date here. If you're on social media, feel free to use our hashtag, Geodisy. We've got a web page on the UBC library there. We've also got a GitHub page where Paul's putting all the code and we're putting crosswalk information and stuff like that. That is our general email, geodisy.info@ubc.ca. So feel free to shoot us an email if you have questions or comments, or you can also tweet one of us. That's fine too. And with that, I think we can open it up for questions. I know there's some in the chat, so maybe we can address those first. And also want to say thanks to everyone for listening.
And I can read the questions aloud too, just for the recording. This is Courtney. Thanks,
Sure,
y'all.
that's great.
This was so great. Thank you so much. I want to go back to Michael's question, and if you want, you could even go back to that slide where you were listing basically all of the steps in the process, because Michael is asking for step number 1, how are geospatial data sets identified by file type like .shp or through information in metadata?
So for actual ones that we're calling geospatial files or geospatial data sets, we are looking for specific file types. So whether it's a .shp or .geojson or .geotiff, but we are determining if it is a file that we can use based on the combination of those files or the existence of entered fields in the metadata.
And we have a question from Jessica Tree-Logan. Does the bounding box metadata field, oops, I lost it. Does the bounding box metadata field in Dataverse have any validation, or can you just type in any old garbage in any old unit?
Yes, I am checking to make sure that at the very least you aren't going to over 90 degrees north or south and not going over 180 east or west. I mean, you could have a number that fits in the valid range that is just garbage, but there's only so much we can do. Part of our plan is not to be curators of the data. So if as a researcher depositor, you put in incorrect information, then that's what happened. That's sort of, we're relying on depositors to accurately represent their data.
Yeah, and yeah, it's a good question. Like, it really does depend a lot on what folks have entered into the Dataverse fields, and they are just open text. And then we've just kind of built in these like quality checkers when we can, like making sure they're valid coordinates, or also using Geonames, which kind of roots out if there's wonky place names. And then we are creating a user guide for depositors, so that is likely going to sit in a few places on Scholars Portal, hopefully. That provides some instruction on depositing, on creating metadata when the researchers or users are depositing it. So hopefully that'll help a little bit too. But yeah, a lot of it is just like the onus is on the depositor.
The reason is we are trying to automate the pipeline. We don't want to be the curators of this pipeline. We want the pipeline to run by itself. So we build it in once, we're fixing it, and then it's a national pipeline that will run by itself for all research data in Canada. One thing to know about our project, it is entirely open source. So if someone wanted to take our pipeline and set it up with their own Dataverse and their own GeoBlacklight, it's very easy to do that. In addition to that, we also made it easy to add currently Dataverse is to our existing pipeline so that it would be through our setup pipeline. So
That's exactly for you guys, for Texas Digital Library, that you both run both Dataverses and the GeoBlacklight. So you could potentially adopt the pipeline and use it for your own purpose because it's all open source. We are very excited about that.
Yeah, I think Jessica Tree Logan, I think that's what she's trying to hint at, not so quietly. But yeah, it's something that we're certainly interested in. I want to ask another question that was in the chat box from Sherry Lake, who is from the University of Virginia and also in our larger Dataverse global community. She asks, what if the bounding box does not match the geographic coverage info?
So if the bounding box doesn't match the geographic coverage info, we are still going with the bounding box. We sort of felt that that is, if someone's putting in a bounding box, that they feel that is what represents their data set. What they put in the geographic coverage, it's possible that that is not as representative of the specific data set. It might just be like they worked in Vancouver, but what their actual area was a much smaller area, so their bounding box is a subset of that larger area. So because there's a bit more ambiguity in the geographic coverage fields, we felt that the bounding box was a safer option if there is a difference between the two.
We do have one quality check there that, like, if there, what is it? I've got to remember it now. If there are more or less file types that GDAL can read than there are bounding box coordinates entered, then we're going to forego the GDAL read, because in that case, maybe GDAL just can't read enough of the files, and then we're going with the bounding boxes. Yeah. So we built in a few different things where we're trying to like make sure we're accurate. We're showing the data as accurately as possible. We're representing it as best we can. But yeah, there is kind of a hierarchy to it.
I have a quick question, and please, participants, you're still welcome to put more questions in the chat there. But my question is about the ease of implementation. So you're talking about the project from your perspective on the Geodisy side. In terms of the Scholars Portal Dataverse, do you know if they had to make any adjustments to the core software? I know that they do a lot of development themselves on Dataverse, some of which does make it into the core, but some is kind of taking a little longer to get there. And so we do try to stay in Texas aligned as much as possible with the core Dataverse software. Do you have that information, or is that something that the Scholars Portal folks would know?
Scholars Portal has not had to change anything on their side. We are only accessing records that are unrestricted records, so we don't need a specific login to access and harvest the records that we're getting. So we're just using the existing Dataverse API to pull records off of Dataverse. So yeah, they don't have to do anything at all.
Exactly. That was the idea behind the project, to use APIs or calls to extract data, all open access data, all freely licensed, to manipulate and present it visually. So we don't have right now any licensed data in Scholars Portal Dataverse. Some institutions run their own dataverses for licensed data, UBC included. We have more than 38,000 files of licensed data. And this is not included in the Geodisy right now. And in our application to expand it, we are still only relying on the API calls to extract data from Islandoras, from Secans and other platforms. So we are not planning to amend the native code for Dataverse or for Islandora or for anything else. So we try to make it really flexible.
That is excellent. Thank you. I have another question from Michael Shensky at UT Austin. No need for apologies, Michael. He asks, is data copied from the Scholars Portal Dataverse to the GeoServer VM to publish a WMS for those data sets? He's wondering if copying the data is necessary or if there's a way around that you've discovered.
So yes, the data sets that we are getting from Dataverse and are storing on our middleware are available through WMS. We weren't able to find an easier way to get dataset preview and dataset download through GeoBlacklight, other than using a sort of intermediary of GeoServer. But GeoServer offers WMS and WFS services, and so that's what we're using.
Good question.
Yeah, that's a good question.
No worries about the hammer.
It's so sorry. It's not only just in my house, it's also the two houses surrounding me are getting work done.
I imagine it's a lot worse for you than it is for us.
Okay, I see that Jessica is typing, so there might be another question coming in. Yes, okay, so she's asking, the download from GeoBlacklight is coming from GeoServer then, and not directly from Dataverse?
That is correct. However, in the GeoBlacklight record, there's a link back to Dataverse, so you can click on that and it'll take you to the Dataverse record page itself, so you could download from there as well.
And also don't forget, we are taking all those records with their clean ISO metadata and making them available for anybody, including you guys, to reuse on GitHub with the open GeoMetadata.
Yeah.
So we are putting all our records there. So if you wanted to include in your library catalog, you wanted to include all Canadian research data, you can take that and they put it in your GeoBlacklight.
And she's following up about a version change. What happens if there's a version change?
Of Dataverse?
I was wondering the same thing.
If there's a version change of Dataverse, like we would have to look into how things have changed and potentially have an update to the pipeline to allow for those differences. That would generally only be an issue with major version changes. Minor version changes don't tend to change the API too much. For file versions. So one thing we are doing, like when I'm harvesting stuff from Dataverse, I'm checking the major and minor versions. So I'm only reharvesting from a file if those have changed. In which case the files themselves would get updated in our middleware as well. If you wanted to go back to a previous version, there isn't a way to do that through our pipeline at the moment. It will only be the most up-to-date version. And I'm scheduling harvesting for every night at like 2 o'clock in the morning our time. So there should be a fairly rapid transition to the newest version since it's going to be updated every day.
Welcome. Well, lots of good questions.
Yeah, thanks everybody for the questions and thanks for the thorough answers, y'all. This has been really interesting today. One of the reasons that TDL is, of course, interested is because we know how much UT Austin would like to enable something like this. And knowing how much work that is on our end is really valuable. And it seems like very little, so it looks like we could actually implement this soon, sooner than we thought we might be able to. So I'm sure you've really made Jessica especially extremely happy today, and probably Michael Shensky as well at UT Austin, and certainly those of us at TDL knowing more details about this work. We can wait a second for any more questions. We have 6 minutes left, but if I don't get a question in the next few, do y'all have any final points you'd like to make or anything else you'd like to say?
No, we are waiting for the next funding announcement towards the end of this week. So by the end of this week, we will know if we are expanding our pipeline to include the rest of Canadian research repositories, which are mostly CCANs, Islandoras, and DSpaces. And if we are successful, we will be working for the 2 more years to expand and perfect the pipeline.
One thing to note is that our middleware code is written in Java.
Good to know, yeah.
Well, our fingers are crossed for you in terms of further funding. It seems like you're on the right track to get it. So good luck with that. And we're, of course, paying close attention here in Texas. We have a really close relationship with Scholars Portal as well. So I'm just going to wait here for 1 more minute in case there's another question coming in.
And if people have questions after this has ended, feel free to email us.
But if you want to see it, our email is there, and Jessica already asked to add her to the IP addresses. So we just email us. We'll add you to the IP address. You'll take a look and see it yourself.
It is an alpha, so I am sometimes removing records from it. So if you hit it and there don't seem to be any records, check back in a couple hours and the records will probably be back.
Right now, there's just a bunch of stuff from Stanford in there.
Yeah, it's mostly stuff from Stanford on there right now that I harvested from Open Metadata.
Oh, yeah. Yeah, I'm excited about Open Metadata too, actually. I was personally not aware of that, and we do try to, integrate with as many of those registry type things as we can from Texas. All right, so I think that's it for questions. So I just want to say a final thank you, and we will let y'all know as soon as the video has been closed captioned and everything is up and available in our repository and on our YouTube channel, so you can share it out as well. Thank you so much, y'all, and I hope the day is not too cold up there in Vancouver.
No, it's
rainy, but not too cold.
Yeah, not cold.
Thanks so much. Thank you.
Thanks
really
for
appreciate it.
Bye-bye.
Thanks, everyone.
Thanks, Shell. Take care.
You too. Bye-bye. Thanks.